In this video, we will be discussing how to factor a GCF out of a polynomial. Remember that a GCF stands for greatest common factor, and that greatest common factor needs to be shared in all of the terms in the polynomial in order for you to take it out. And when I say the words take it out, I mean something that we can divide out of all terms. So we're thinking in terms of division. You'll be expected to apply your knowledge in class, so please pause or replay if needed. Please make sure that if you have any clarifying questions, you either wait and write them down to ask me, or you replay the video so that you can get a better understanding. So remember, we've been talking about how to factor polynomials for some time now. A binomial, you need to make sure that you know what that is. That is an expression that has two terms. There are specific binomials that can be factored using a technique called dots. Dots would be a situation where you have something like x squared minus 4. 4 is a perfect square. We have subtraction holding these two terms together, and we have an even exponent. So if I were to factor this, I would get an x in both places. The square root of 4 is 2. So remember, we're not cutting it in half, we're taking the square root. And then these two factors should have opposite signs. So that would be how you factor using dots. Then we spoke about how to factor trinomials, and we factor trinomials by making sure that we can look at this trinomial, and the number in the middle, which is b, is going to be the sum of the two values in your factors, and c is the product. So we use a sum and product puzzle, which we've drawn an x on our papers for a while now. The sum is what goes on the left, and the product goes on the right. And then you are usually asked to find these two numbers that will make this true. Today, we're going to be taking this a step further, and we're going to be talking about how to take out a GCF. Notice how this step comes first in the family tree. That will always be true. So if there is a GCF, you need to take it out first, no matter if it's a binomial or a trinomial. And then you can use the techniques that we've talked about in class to factor it further. So this will be what we're discussing today, how to start with a GCF, take that out, and then continue through the factor tree and what we've talked about with factoring. So first we're going to talk about if the GCF in your expression is just a constant or just a number. So if we look at this first example, we're going to do it together. 4x squared plus 12. Now this is a binomial. It is not dots though, because 12 is not a perfect square and it has addition in the middle. But if we notice, 4 and 12 are both divisible by 4. So we can factor out a 4, which is really division. So if we divide both of those terms by 4, we're left with x squared plus 3. So our final factored form for this would be 4 on the outside, and really there's only one factor left in the inside, which is x squared plus 3. Now I know this doesn't look like all of the other factoring techniques we've talked about, but this is why it's new. We're taking something out and creating a factor from what is left over. Pause the video and please do the you-do, which is 6m to the third plus 18. See what you could factor out of both of those terms. Then replay the video to check your answer. Factoring this using the GCF, you should notice that the shared common factor, which is the greatest common factor between those two terms, is 6. So when I divide 6 out of both of those terms, I'm left with m to the third plus 3. Just don't forget to make sure that you include this 6 on the outside, because it's not that it disappeared, it's just that you factored it out. So you need both the 6 and this factor to have your final answer. So now we're going to move on to what if we could take more than just a constant out, and we could take a constant and a variable, or just a variable. I always like to start by looking at the numbers here. And I'm looking at 14 and 8, and I'm thinking, okay, what are both of those numbers divisible by? Both of these numbers are divisible by 2. So I'm going to factor a 2 out. So when I do that, I get left with 7x to the third power plus 4x to the second power. But if you notice, I still have x's in both terms. If they share a common variable, you can take that variable out. The question is, how much can you take out? So this one has x to the third, or 3 x's, and this one has x to the second, or 2 x's. So the most I could take out of both is always going to be your smallest number. So I can take out an x squared because both of them have at least 2 x's. So when I do that, I get 7, and since I took 2 out of here, I'm left with 1, plus 4, except this time I took out all of that x squared. So all I'm left with is 4 there. So the last step that's a little new, because now we took out more than one thing, is that we have 2 terms on the outside that we took out. So we just string those together using multiplication. So I have 2x squared on the outside, that's what I took out. And I'm left with 7x plus 4 on the inside. So my final answer is 2x squared on the outside and 7x plus 4 on the inside. So pause the video, try the you do, and then replay the video once you're ready to check your answer. Hopefully you were able to get 2x to the third. That could be your greatest common factor that you took out. And x plus 8 is what's left over because I took out 3 of the x's. There were 4 here, so one of them's left over. There were 3 x's. I took them all out, so I'm just left with that 8. And both of those numbers were divisible by 2. So now that we know how to take a GCF out of an expression, we're going to take it up a notch. So what if you were able to take a GCF out and then what you were left with ended up being a dot situation, so you could keep factoring further? Notice how the GCF is always your first step. So first we're going to look here and say, okay, 2 and 18 are both divisible by 2. So when I take that out, I'm left with x to the fourth minus 9. So I have 2 x to the fourth minus 9. And in this case, I couldn't take out any of the x's because both terms didn't have x. But now looking at this, I notice that this right here has subtraction. It's a perfect square, and it has even exponents. So I can factor this into x squared plus 3 and x squared minus 3. But don't forget, one of the biggest mistakes people make is they forget to keep that 2 on the outside. So our answer is actually 2 times x squared plus 3 times x squared minus 3. I didn't keep going because 3 is not a perfect square, so that's how I know that I'm finished. Please pause the video and give the next one a try. See if you can factor it completely. Then push play to check your answer. Hopefully you were able to see that 3 was our GCF, and that was what we could take out of all terms. From there, we were left with 4x to the fourth power minus 9, which is a dots because we have perfect squares, subtraction, and an even exponent. And when we split that up, square root of 4 is 2, square root of 9 is 3, and then we split that x squared in half, keeping our signs opposite. Again, don't forget to keep that 3 on the outside all the way through, otherwise your factors are incorrect. Finally, we're going to move to what if you could factor out a GCF, but then instead of it being dots, it was a sum and product situation. Notice how now we're talking about trinomials instead of binomials in those top 2 examples. So I'm going to start by saying, what can I take out of 3, 12, and 36? I can take a 3 out of all 3 of these terms. When I do that, I get x squared minus 4x minus 12. So now if I look here, I need to think about two numbers that are going to multiply to negative 12 and add to negative 4. The reason I have to do that is because technically now I have 3 times x squared minus 4x minus 12. And I need to see if I can factor this trinomial further. So here if I look, I have 12, so I'm thinking 3 and 4, but 3 and 4 isn't going to work. What about 6 and 2? And I need them to add to a negative 4, so I need this 6 to be negative and a positive 2. That will, in fact, give me a product of negative 12, so I have my factors. So I have x minus 6 and x plus 2. So now I was able to take the GCF out, which allowed me to do the sum and product with the rest. Pause the video and see how you do with the last we do. Push play when you're ready to check your answer. Hopefully you were able to factor out a 2 as your GCF, and then using the sum and product puzzle, I was able to see that my two factors would be x minus 4 and x plus 3. There are a couple exceptions to these rules that we are talking about, and they're ones that I want to make sure that we talk about. So here, if we're talking about a situation where we have 2x squared minus 3 plus 8, if we look at these terms, 2, 3, and 8 do not share any factors. So there is no GCF. We also have not then talked about how to factor this because it has a number in front, which makes it messy. So this would be a situation where we would just leave it and we wouldn't factor it at all. This is non-factorable at this point. Additionally, if we look at this one, we see 4, 12, and 20. So there is a GCF there, and my GCF is 4. If I take a 4 out, I get x squared minus 3x plus 5. Except now if I were to go and do the sum and product puzzle, I need two numbers that multiply to 5, but add to negative 3. And the only factors of 5 that work are 5 and 1, because 5 is a prime number. But there's no combination where I could add 5 and 1 together to get negative 3. Even if I made both of these negative, that would end up making it a negative 6. So this one, you can't keep going any further, even though it looks like you should be able to do sum and product. So my final answer for factoring this one would be to just leave it in this format. So sometimes we can keep going and sometimes we can't. You have to use your knowledge of factoring to first take out a GCF if possible, and then use either dots or sum and product to continue factoring. Sometimes you'll be able to do some parts of this factoring tree, and sometimes you'll be able to do none of it. So going back to this idea, first you need to make sure that you factor a GCF out of your polynomial, and then if it's a binomial, you want to see if you can use dots, and if it's a trinomial, you want to see if you can use the sum and product puzzle. Today, we were able to talk about how to factor a GCF out of a polynomial. So if you have any further questions, make sure to write them down, or please make sure to replay the video to gain more understanding.